Absorbance is surely one of the most common techniques in spectroscopy, allowing both quantitative and qualitative results. The output you get from any absorbance measurement is a spectrum. In this case, as an example, we have the absorbance spectrum of eosin Y. Let's start by the x-axis. Here we have the wavelength information in nanometers. To this section, we can call the qualitative section of your spectrum, as it allows you to identify the compound in your sample. Typically, the wavelength that corresponds to the maximum absorbance for a specific compound, and its spectrum can be used for its identification. Almost like a fingerprint, making absorbance a powerful tool for sample qualification. And in the y-axis, you have the absorbance value. To that, we can call the quantitative section, as it can be related to the concentration of a certain compound in your sample. The principle is that a lower concentration will correspond to a lower absorbance value, and a higher concentration will correspond to a higher absorbance value, and more. The relation between absorbance and concentration is linear. So, by knowing the absorbance value of a compound, you can easily get to its concentration, and that's valuable quantitative information. Now that you know the basics of absorbance measurement technique, let me show you its typical fiber optic setup. This is what we call spectroscopy. Out of the box. Detector, sample holder, light source are all independent components and connected via optical fibers, which gives you the freedom to configure the setup that best suits your application. At SARSpec, we have solutions for absorbance measurements from the UV up to the near-infrared. Also, you can do this with liquid, solid, or gas samples. You can use a traditional 10mm cuvette, smaller or bigger. Perform flow analysis with our flow cells, or even measure inside a container with a transmission probe. For a complete solution in spectroscopy, we have the fantastic LightScan software. We'll leave that for another video, but be sure you don't miss it. I promise it will be worthy. Cheers!